Recalling the properties of geometric series in the form a times r raised to the n minus 1 is equal to a plus a times r plus a times r squared, etc. A sum of a geometric series like this, if it is convergent, can be written like so. This is the formula for the sum of a geometric series. And basically what this is going to lead to is this idea, that these two things, since they are the same thing, what we can do then is take a function in this form and then reverse engineer it so that instead of being a function in its more familiar form, we can write it as a sum of an infinite series, which is a power series. And again, basically the idea is that these two things are the same thing. We've got the sum of a geometric series. It can be written like this, or it can be written like this. Think of the number 1. I can write it like this, or I can write it as 2 halves, or I can write it as 2 quarters plus a half, or I could write it as the sum of an infinite series. So the idea now applies to functions we are more accustomed to seeing, something like 1 over 1 minus x. F of x is equal to 1 over 1 minus x. If I look at this formula right here, I can see that I could write this as a geometric sequence or series, I should say, where a is equal to 1 and then x is equal to r. So I could write the function like this, or I could think of it as 1 plus x squared plus x to the third all the way to infinity, and it can be written just like this instead. And of course this is assuming that it is convergent where x is less than 1. So let me do a very simple example of another one. So f of x is equal to 1 over 1 plus x squared. This one's easy enough as well. A is equal to 1. Now I'm going to convert it to this form, to a power series. You can see I got minus x squared by thinking of it like this. A is equal to 1. I was going to put a up there, but it doesn't really matter. So minus, so that's what I was thinking. Well, I'd be in there. But that's what I was thinking about, in case you were wondering. And we can also convert this into something more familiar. Not really familiar, but that people see in textbooks more. Something like this. And what this is equal to, put it down here. So you put in 0, that's 1. Actually, the next one will be minus 1. X squared, and then x to the 4th. It's an ugly x. Just like that. So this is how we convert functions to a power series or a geometric series. Power series is a geometric series, but it's basically reverse engineering this idea that was learned way back in probably college algebra or something like that. The sum of a geometric series, if it is convergent, has a value a divided by 1 minus r. And if we have a function in this type of form, then we can use a and r values to convert it into something like this, or like this. Doesn't really matter, it's basically saying the same thing. That's how that's done.